Geoengineering is the extensive and large-scale interference in the Earth's climatic system to modify it and thus mitigating climate change and counter consequences. Climate moderation by using climate engineering is not a widely accepted idea. Many scientists still value reducing emissions by changing human behaviors over climate engineering. We have already made so many interventions that have caused disturbances like sea level rise, glacier melting, and wildfires. Public figures and environmentalists avoid talking about climate engineering because it may lessen the motivation to reduce emissions in people. Solar geoengineering refers to diverting the path of solar radiation away from Earth by significantly increasing the reflectance of the atmosphere and surface of the Earth. Solar geoengineering is an expensive technique and would require a lot of wealth. The methods used in solar geoengineering can be separated into 3 different categories which are described below. To increase the reflectance of the atmosphere, stratospheric aerosol injection, cirrus cloud thinning, and marine cloud whitening are ways. Stratospheric aerosol injection involves scattering an aerosol layer of sulfur in the atmosphere, which would increase the reflectivity of the stratosphere. In this way, less radiation will reach Earth, and more of it will be reflected into space. Another method to increase reflectivity is marine cloud whitening. This method focuses on increasing the albedo of clouds. Marine clouds will be sprayed with seawater to make them whiter to increase their reflectance. Cirrus cloud thinning is another proposal in climate engineering techniques. Cirrus clouds are made up of hard ice which has more heat absorbance than other clouds. Cirrus cloud thinning technique will make these clouds thinner to reduce global warming. Increasing the albedo of the surface includes modifying plants and ice to increase their reflectance and mounting reflective materials on top of buildings. Space-based methods of solar geoengineering involve the placement of giant space mirrors in space that will reflect sunlight away from Earth into space. Carbon geoengineering focuses on the removal of carbon dioxide and other greenhouse gases from the atmosphere. It can be done by promoting natural ecosystems such as forests, parks, and blue carbon ecosystems. Carbon geoengineering is capable of dealing with both rising temperature and greenhouse gases. Following are some of the methods of carbon geoengineering. Afforestation can help to absorb excess carbon dioxide from the atmosphere by photosynthesis. Afforestation in desertified areas that will bring a cooling effect, thus lowering the Earth's temperature. This technique of carbon dioxide removal involves fertilizing the ocean to promote the growth of specific kinds of algae and phytoplankton that would absorb the carbon dioxide. Iron and nitrates would be dissolved in the oceans that would promote the growth of phytoplankton and algae. Oceanic ecosystems like seagrasses and coral reefs sequester carbon for years. Biochar is a type of charcoal formed when plants and animals decompose in the absence of oxygen. Decomposition in the absence of oxygen gives rise to a process called pyrolysis, which converts biomass into charcoal, biochar, and releases very little or no carbon dioxide. Many scientists and environmentalists condemn geoengineering because of its negative impacts. Ocean fertilization can give rise to algal blooms and eutrophication, which would be devastating for the environment. Spreading aerosol particles in the atmosphere would adversely affect the climate of specific regions. Reflecting solar radiation away from the Earth can cause irregular temperature changes. Rainfall and wind patterns may get disturbed, which would change the geological formations.